We're Team Spirit of Adventure, and this is Project Walgie. I'm Daniel Crook.
I'm Lucas Robbins.
I'm Mika Mildenberger.
I'm Cordelia Kohuth.
I'm Isaac Goldner.
I'm Albie Torcal.
I'm Bruce Barnstable.
The team measured the levels of ozone, methane, and carbon dioxide gases as altitude increased. We planned to compare the data we collected to data collected in years past.
This is our concept of operations. As expected, all systems powered on prior to launch, and during ascent, through burst, and descent, all sensors, environmental and gas sensors, successfully recorded data, and including the burst at 100,000 feet. We successfully recovered and got access to the data during flight, and we're currently looking at data analysis.
Our ozone sensor behaved as expected. Its output in millivolts is proportional to the amount of ozone gas present. So in between launch and burst, the concentration of ozone gas rose as we rose into the ozone layer, and then decreased as we came out of it until burst. And then the same happened in reverse much quicker in between burst and landing. Our methane sensor mostly behaved as expected, except for the time in between burst and landing. We are still trying to understand what this data means. We are assuming that there was some sort of malfunction in the data, possibly due to the turbulence after burst, but in between launch and burst, the data is as expected. Our carbon dioxide sensor behaved as expected. Its output in millivolts is inversely proportional to the amount of carbon dioxide gas present. After launch, the amount of carbon dioxide decreased and then increased until burst, and then decreased and increased again until landing, which aligns with our expected data.
All of the basic sensors on our BalloonSat functioned as they should. The pressure sensor functioned properly with the pressure slowly decreasing until burst and then increasing back up to what it was roughly at launch. The humidity sensor also functioned properly with the humidity decreasing as the altitude increased, and there are slight fluctuations in the humidity, but this is likely due to varied humidity conditions from day to day. The acceleration from the accelerometer in both the X and Z directions functioned properly, with a significant acceleration during launch and then roughly constant throughout the ascent until burst, and then it showed a significant increase in acceleration after burst until landing, where it's then constant until we retrieve the BalloonSat.
Both of the temperature sensors performed as we expected them to, with the external temperature sensor decreasing from launch until the tropopause and then re-increasing until burst, and then on the way back down it decreases until the tropopause and then increases till burst. The internal temperature is roughly the same throughout flight and then increases after landing, and this was likely due to sitting in the sun until retrieval.
In terms of pictures, we set the GoPro to take a picture every 10 seconds. It successfully did this all the way from launch to burst and then right back down to landing.
At the end of flight, Project Walgie gas sensors experienced a significant amount of increased output voltage. This was likely due to the draining battery supply, but moving forward we will be performing tests to make sure that this was the actual cause. And there was also a significant decrease in the methane output at burst, and this was most likely due to extreme burst conditions.
Here, moving forward, we will need to get in contact with another scientist or organization that can provide us with known concentrations of the gases so that we can calibrate our sensors. We need to calibrate the sensors in order to find the output voltage of those sensors in parts per million so that we can interpret our data. The actual collection of these sensors will not take more than a few hours, so the longest part of this process will actually be finding someone who can provide us with these gases. All in all, our project was successful, and we have a solid plan moving forward for what we need to do from here on out.